And we are live. Hello, everyone. Once again, my name is Sanket, and I welcome you all into today's session, where we will go ahead and talk more about data science. As you already know, the topic for today's session is understanding what data science is all about and accelerating from Excel to Python. This will help you go ahead and understand the transition into the world of data science. Now, in order to go ahead and talk more about it, I am very happy and delighted to welcome to all of you, Jeffrey Dittenberg. Now, Jeffrey is a well-renowned personality, both in United States of America and Asia. He has taken multiple projects in his tenure of, I guess, 15 odd years. He is a passionate guy for mathematics and has worked as a mathematics instructor professor with multiple colleges and institutes. And he also possesses very high amount of knowledge when it comes to data science. He has not only taught more than thousands of students all across the globe, but he has also solved multiple business problems using data science and analytics. So without further ado, let me go ahead and pass on the mic to Jeffrey so that he can go ahead and get this session kickstarted. Jeffrey, you can hear me, right?
Yes, I'm able to hear you.
All right.
One moment while I share my screen here.
Yep, you can do that. And guys, just let us know if you are able to see the screen also.
All right. So I believe I'm visible and audible. Everyone can see me, right? And hear me. If you would just give me a quick Y or N in the chat, that'd be great. Very clear. Okay, perfect.
All right, Jeffrey. So the mic is all yours. You can take the session.
Great. Thanks so much for your great introduction. Very, it's always nice when people say nice things about you. Always a really good. So first of all, thank you for, I'm very excited to see so many people who are also excited about data science. To me, it's something that basically I came to data science about 3 years ago. I've been in mathematics for quite some time, but before I was doing pure mathematics and then some applied mathematics and teaching mathematics. And when I was in graduate school to get my master's degree, I started to really study statistics and probability and quantitative methods and this type of subject, which led me down the road to data science. So you could say that, you know, all of you who are here who are not freshers, who have a tenure in some career position, I can relate because I'm also coming to data science as an adult. And luckily for me, I have a background in mathematics. So there's an ongoing sort of controversy, you know, do data scientists need math or not? So some people say, yes, you need it. Some people say, no, you don't need it. And, you know, the truth is our technology is so great that you can't actually, you know, do a lot of data science without knowing a whole lot of mathematics. But because I'm in the mathematics origin, I'm the one that says, yes, you do need mathematics. So, you know, really it's a very open field, and it's not incredibly difficult to get into if you have the correct discipline and you have the ability to deal with solving problems. Okay, so before I continue here, I would like to get a response from some people, and I just want to know, what is it you want to get out of this particular presentation? So why are you here, basically? Like this. You know, our topic is transitioning to data science. So I wanted to know, like, how many of you are in that position where you're either you have one career and you want to switch to data science, or you want to sort of make a lateral move in your current position. So can I get some feedback in the chat from that, please? It might take you a moment to type it up. Okay, lateral. Yeah, okay. Shifting, newbie. Okay, good. So I see some people career transition, work as a data analyst. Okay, shifting career switching. No fits for me. Okay. Oh, very good. Specialize in it. See, I'm very fond of people who specialize in statistics and mathematics. Upskill career grade. Okay, great. Well, so then career shifting. So everybody has, their own path to data science, and I've told you a little bit about mine. And I really did fall in love with the solving of problems when it comes to you get a problem that can be a business problem, for example, or a problem in academia where you're studying students and their success rates and so forth. And you have to turn that into a problem that can be answered using machine learning algorithms or deep learning. So you turn a business problem or a problem in academia into a data science problem. And then from there, it's a matter of writing a certain kind of code that we can explore the data. And from that, we can get some insights just without using any data science alone, just analyzing the data, we can get insights. And then from there, we can build models using the libraries, specifically in Python. Now, I have used R programming language before, and that's what I used in graduate school. But I really, and actually, when I first started learning Python, I was always comparing the two, saying that, R was so much better. But then as the time went on, I started to see how versatile Python is, and how once you sort of achieve that learning curve at the beginning, the limits are taken off, and whatever you want to do with Python, you can do. It's a very, what we call a high level language, which means that it's easy to learn because it's more like English than languages like C or Java and so forth like this. Okay, so let me just give you a little bit of background about data science and where it came from. So the first time somebody used the word data science on record was in about 1960, and then again in 1974. There was a statistician or a computer scientist named Peter Noir, and he was the first person to basically describe the word data science. And back then, it was a part of statistics and a part of computer science. And there's a meme that you might have seen maybe on LinkedIn, and I didn't grab it, but it's of a dinosaur. The dinosaur has the word computer science on it, and it's eating statistics. And so basically, you might think of like data science as like it's statistics sort of re-envisioned by computer scientists. And so there's a lot of parallels, and there's a lot of algorithms that are in both domains, and they might have a slightly different name or a slightly different formulaic representation in data science, well, as a computer scientist might present it, as opposed to a statistician, but they're accomplishing similar things, which is taking data and then gaining insights and analyzing it, and then also using different algorithms, machine learning models, statistical models to predict and or classify this data. Okay, so you may have also heard of deep learning. Deep learning is an extension of machine learning. And deep learning was actually first conceived of in 1943 by McCullough and Pitts. And the idea was to create a model that would be similar to how the human brain works. So in the human brain, we have these things called neural transmitters. And the basic cell in the human brain is the neuron. Do I have any biology majors in here? So keep me honest and tell me if I'm telling this story incorrectly. But in the human brain, there's a cell called the neuron. And basically it works the way deep learning works. We have neurons in deep learning and they're part of something called a neural network. And if there's enough weight, then something will pass through it on to the next, right? And that's basically how the human brain is working. You have energy differentials. And if there's enough energy or electricity, then it will pass through and you'll get the signal, move my arm or, move my legs like this. And so neural nets are what deep learning is all about. And you may have heard, and I'd be really surprised if you had not heard about something called an LLM, or a large language model, which is what the famous ChatGPT is. Now, these are neural networks. They're based on neural networks that can take actually billions of parameters. So parameters, if you don't know what a parameter is, basically we feed it this information and it learns from it. So it's sort of a misnomer to say machine learning, because the machine itself is not learning. It's the model that we're training. So basically we're model training. So let's talk a little bit about data science. First was a part of statistics, or a part of computer science, and it was re-envisioned by computer scientists. And then as the years went on, more and more data became available. And the value of being able to analyze data became extremely evident. And by the time it got to be around the 2000s, we have the internet, we start to have smartphones I'm not really sure when smartphones started, but the point is that nowadays, there's so much data available, it's incredible. So there was a scandal in 2016 with a company called Cambridge Analytica. And I won't get into the details of the scandal, you can look it up later. But one of the things that they said about their data was really interesting. So before I tell you what they said, let me just ask you, if I ask any of you to sit down right now and tell me 10,000 things about yourself, can you do it? Who thinks they could write down 10,000 facts about themselves right now? Just give me a yes or no. What do you think? Do you have time? No, you can't. No, neither can I. And I wouldn't want to, because gosh, enough of me is, there's so much, there would just be too much of me, right? So Cambridge Analytica claimed to have 10,000 data points on each of the individuals that they had data on. So if we're saying, if you're saying to me and I'm saying to you, I can't think of 10,000 things about you, or about myself rather, and you can't think of 10,000 things about you, then what we're saying is that this company that collects data knows more about you and I than we know about ourselves. Okay, so if that isn't a thought that makes you sort of just, I don't know if it can frighten you or make you feel excited about the power of data, but it's pretty amazing to me. So why learn data science? And if you are already working in some sort of like business analyst or data analyst or financial analyst where you're using Excel, why move to Python? And the first very big reason is because of something called massive digital transformation. So the World Economic Forum, they do a survey every so often. This survey was done in 2023. And what they did was they asked their respondents, how many of you expect to adopt these different things in the next 5 years? So 86% of the 86.4% of the respondents said that they will adopt digital platforms and apps. Okay, so that means more data is being collected because every time you use your phone, every time you use your iPad, they're collecting data. Education, workforce, and development technologies. Okay, that was 80.9%. So again, even if you decide not to become a data scientist, you want to become you want to work as in the field of ed tech. That's a big one. And then number 3 here is big data analytics. And really what I want to focus on here is big data analytics. And then you can go down the list, you can see artificial intelligence, which artificial intelligence is also based on machine learning and deep learning. Okay, it's using machine learning and deep learning to allow for something that appears to be human-like, or something that appears to be sentient. but it's actually based on probabilistic models at the very end of the day. But big data analytics right here is 80.0%, right? So this is a massive digital transformation, meaning that even if you're using Excel now and you're very good at it, it's likely that the amount of data that's coming, Excel won't be able to keep up. Right now, I think Excel can only handle about 1.5 million rows of data, right? So if you have more than that, what can you do? Well, you can use Python. Okay, so the first massive thing to think about is the massive digital transformation. And there's a word for this, this thing that's happening right now, especially with the AI that's been coming out. That's everybody's, there's been a lot of controversy about AI, and especially about, is it dangerous? Can it overtake humanity? And then on the other end of the scale, people are wondering, what are the good things it could possibly do? And do I have to worry about it as far as taking my job or, along these lines? And having used ChatGPT myself, I can tell you there's no possible way it's going to take your job in data science or data analyst job, because it's often wrong. And so you'll spend a lot of time debugging that, just like you would any code. But the point is, with this AI and with all of the deep learning that's in all of this big data analytics that people are adopting, that 80% of these respondents are adopting, and the digital platforms and apps that 86% of these respondents are adopting, there's a name for what's happening. It's called a disruptive innovation. Okay, so disruptive innovation, you've seen this before. Who remembers renting a movie from Blockbuster? Does anybody remember that? Anybody used to like to go to Blockbuster and walk up and down the aisle and try to pick a good movie to rent? Anybody remember that? Yes, yes, yes. But can you find a Blockbuster video now? Not likely, because what happened? Well, Netflix happened. And in Netflix, oh, you have Video City? Okay. But also there's Netflix. And what Netflix did was it replaced Blockbuster. It performed a better job at a lower price. And that's what's going to be happening when we get more and more data. We're going to have to adapt to it. So let me just explain how much data is in the world right now, and then how much there's going to be. So first of all, a byte is the basic unit of information in computing. Okay, so I'm not going to go through all these, but I want to talk about a zettabyte. Okay, so 1 zettabyte is about the size of the Sahara Desert. Okay, so this is an oversimplification, but if you consider 1 byte of data to be like 1 grain of sand, then 1 zettabyte of data is 1,000. I'm sorry, it's 1,000 Sahara deserts, not just one. So 1 zettabyte is the equivalent of 1,000 Sahara deserts of sand. So in 2021, there was a study done showing that there are 79 zettabytes of data available in the world, and that by 2025, that was expected to double. So that if you consider 1 zettabyte of data to be equal to 1,000 Sahara deserts of data, then that means that here now we have 79,000 Sahara deserts worth of data. Okay, so do you know how big the Sahara Desert is, right? It's about as big as the United States if you include Alaska and if you include Hawaii. So this is a massive amount of data. And if you're a statistician, you might say, well, more data doesn't necessarily mean more accuracy, which is true to a large extent. But more data does mean more parameters for things like deep learning models. So as the data grows, then even in the current companies and in future companies, the positions and the roles that were currently occupied by people who were vastly skilled with Excel will have to necessarily change, and it will it will be necessary to learn Python or some language like Python, and to also gain these additional skills of machine learning and deep learning in order to complete gaining insights and doing analysis on data. So what about data science? If you ask 10 people what data science is, you might get 5 or 10 answers. But basically, it's an interdisciplinary field that's gaining insights from data. But the thing is, if you go to LinkedIn right now and you look at all of the data science job offers that are posted, you're going to see so many different job descriptions. So as a data scientist, you not only will need to know something about data analysis, you'll also need to know something about machine learning, something about deep learning, but also you'll need to know about ML ops, and then about databases, and you'll have to know a little bit about data engineering. So by the time this digital transformation is complete, or if it continues to grow, all of these skills will be very, very valuable. The next thing we want to talk about is, basically that's what I just said. So sometimes you have to forgive me. Sometimes I get ahead of my presentation and I say what the next bullet point says. So I hope that's okay for you. So then Excel versus Python. Now, Excel is a wonderful thing, and I don't think Excel is, I think Excel is great. I actually first learned data analysis on Excel back in 2017 through a course that I took. And I learned all about pivot tables and creating different visualizations in Excel. But what I've learned in Python, I think is much more powerful. And let me just go through a couple of different points for Excel and Python. So Excel is definitely great for analyzing small data sets and for doing simple computations like your descriptive statistics. And even Excel, you can do a regression model. With Python, you have a much better, a much more efficient way of dealing with large data sets and doing more complex computations. So scaling your data, cleaning the data, pre-processing the data, which, if you've ever dealt with data, that's a lot of your time is spent on preparing the data and getting the data ready for you to actually analyze, which is takes usually very little amount of time, especially with Python, when you can automate much of your analysis. So what are the benefits of switching to data science in Python? First of all, as I mentioned, it can handle larger data sets. So Excel can go up to about 1.5 million rows, but in Python you can use very large data sets. Also, you can do more advanced analytics. So you can perform, not only can you perform the regression analysis, but you can also test your data for normality. So there's a library in Python called stats models. And so the basic, one basic concept in Python is libraries. And Python is filled with free libraries. And by the way, did we mention Python is completely free? And people have worked, and actually Python is created by, I can't remember his name right now, but the Python is actually written on top of C. So it's a really interesting story. I don't want to get into that right now, but in Python, you can do, not only can you do your regression analysis like you can in Excel, but you can also do follow-up statistical tests. Like you can do the Shapiro-Wilk test to check your data for normality. I think you might even be able to do the Anderson-Darling test. If those don't sound familiar to you, don't worry. You might learn it in someday if you study more about data science. So you can do other tests, and then more than that, you can do deep learning. You can automate. This is one of the big benefits of Python is automation. If you write one chunk of code, you can reuse it. So there's reusability over and over again. And, you can make custom visualizations. And thank you. Somebody says Guido von Rossum. Thank you. I forgot his name. Thank you very much. I know it's one of those names where you're not sure if you're pronouncing it correct. Yes, Guido von Rossum. And I was thinking of the person who created GitHub, which was his name is Linnaeus. I think he also might have written C language. I'm not sure. Okay, so let me get back to here. So everything that you can do in Excel, you can also do in Python, but you can scale it, and you can use something that's really important called version control. So does anybody know what GitHub is? Have you heard of GitHub before? Yeah. So yeah, exactly. So in Python, you can connect your project to a repository, and if you're working in a global team, everybody can be contributing their parts into the repository. And so you have version control, you have the ability to collaborate across the globe. And then you also have the ability to make visualizations. One thing I didn't mention yet is that you can connect directly from Python to databases, whether it be SQL database or MongoDB. And you can also, you also have the ability to package your projects. So you can package your data science or your machine learning project, and then you can allow other people to download the entire project and use it. You can do what's called deploy into a cloud. So usually people are using things like AWS, Amazon Web Services, or Azure. And using Python, you can create projects that are deployable, which means that basically this service will provide a hosting site where you can go there and you can either create some sort of a dashboard, or you can create an input to run your model that you've built in Python. Okay, so it can get a little more technical, but I won't get too deeply into that. So what are the steps to transition into data science? So first of all, you need to learn a programming language. I recommend Python. I've used R before. R is fine, but I think the learning curve with R is a little bit more than with Python. And if you plan on getting a position working with Python, if you plan on getting a position working in data science, you're more likely to find that Python is required rather than R. R is often used in academia, I've noticed, and especially in life sciences like biology, social sciences. So Python is definitely recommended because it's a high-level language and the learning curve is not as steep as some others. Understand data analysis libraries. So we have basically every time you start a machine learning project, you're going to import these libraries that have functionalities that you can use. The pandas library is basically like Excel times 1,000. So once you have pandas, then you can use NumPy. NumPy is basically a replacement for a very, very old program called MATLAB, I believe. So a long time ago, people used to use MATLAB. And then when Python was created, NumPy became the scientific computing library to replace that in Python. So in NumPy, you can do numerical calculations, you can do linear algebra, you can deal with matrices and vectors, and so on and so forth. And actually, you can create arrays in NumPy. And we also have matplotlib for visualizations, and there's another called Seaborn. So basically, those are the big four: pandas, NumPy, matplotlib, and Seaborn that will be imported into every library. Okay, so study statistics. You do need statistics. Just say to yourself, if you don't like mathematics, just say, statistics isn't really mathematics. But it is. But luckily, statistics that's used in data science, we're talking about like descriptive statistics. We want to know what's the mean value, what's the standard deviation, and then you'll need to understand something about loss functions and cost functions for different machine learning models and this sort of thing. Machine learning, there's a host of machine learning algorithms you can learn. Most everybody starts with the linear regression, then moves to logistic regression, and then we go on to different types of classification and regression models. And then from machine learning, you could go to deep learning. And then you need to practice, practice. Build a portfolio, use GitHub Pages, and you're able to create a portfolio to show your employer or potential employer. Another thing you could do is once you know Python, you can start to take on projects in your current position and use that data to build your portfolio and work on projects. Okay, so now I've got a quick demo here, and I would invite you to code along with me if you'd like to. It's certainly not mandatory, but I thought it would be more fun if you also could join me. So what I'm going to do now is I'm going to open up something called Google Colab. Now, one of the other benefits of Python is that it's there's like 100 different ways to use it in different scenarios. So we have these things called IDEs, which is interpreter environment. I can't remember what IDE stands for, but basically it's like how you use your Python. And there's Jupyter Notebooks, there's VS Code, there is the Google Colab, which I'm using now. And the reason I'm using Google Colab now is because it's incredibly lightweight. It's free. It instantly remembers everything for you. And before I get started here, I'm going to send you a link to it in case you want to join me. And so it's one of the very easiest IDEs that you can use. So actually, go here first. So let me send you the link, and you can just Google it if you like. Now, when you open it up, it's going to ask you to create like a you're going to want to open a new notebook, and that's going to be on the bottom right. Okay, so here's the link if you want to follow along with me. So that's for most crypto. Okay. All right, so now once you have it open, we'll start. And the first thing we're going to do is import some data. So I have some data on my GitHub, and it's at a particular link. So actually, before I import the data, let me share one other thing with you. So because I realize maybe you won't be able to type in real speed, and I want you to be able to have this later so you can use it, I'm going to share this code share with you. And so everything I type, I'll paste in the code share, and you can get it. But please don't erase anything or change anything. So as I mentioned a moment ago, the first thing you want to do in every project is import your libraries. So let me get rid of this cell. I don't need it. So we're going to import the basic libraries for analysis or for data science, which, as I mentioned before, we've got our pandas. And I'm saying as PD. Now, okay, I don't want to explain every single thing because we'll run out of time, and I want you to see some interesting things. So if you have a question about some specific thing, just let me know in the Q&A. Okay, so import pandas as PD. I'm using PD because every time I use a function from this library, I have to use the word pandas. So I want to use PD instead. Okay, so now I'm going to import NumPy as MP, import Seaborn as SNS, and then import matplot lib dot pyplot as PLT. Okay, so I'm going to just copy this. I'm going to paste it on my little code share over here so that you can go ahead and grab it. So you should be able to copy and paste that now if you're following along with me here. Okay, and let's see. Yeah, I can see people are able to get it now. Okay, great. So the next thing I'm going to do is I'm going to import my data. And usually I call my data frame df just because it's easy to do. And if I write some code, I can reuse it. And I don't want to rewrite my code, the same code, over and over again. So if I write my code one time, I use df, and that's going to cover like every time I import some data, I use that same thing. It will be easy for me to reproduce or reuse. So here is the link to the data. And what I need you to do here is you're going to type in df equals pd.read _CSV. So I'm going to paste this in the code share also. And so you can grab that. And so now I'm just going to push this here, or you can do Shift Enter, and it's going to bring in our data. So if you don't mind, I'm going to stop the video so that you can see the full screen here. Okay, so the first thing we can do here, once we have our data, it's a good idea to examine the number of rows and columns, so the dimension. So the first thing I'll do is look at the shape of the data. And here we can see that this data is 75,000 rows, so 75,000 observation, and 15 features. Now, you may have heard the word variable. Variable and feature have the same meaning. Okay, so in data science, we call them features. So we usually have features and then a target feature. So in this case, we have 14 features and one target variable. Okay, the next thing I want to do, we can just get an idea of what the data looks like by typing in df.head. Okay, so let me update this one. So that's going to give me the first 5 rows. And if you want to see more than 5, then you can just put a number inside the parentheses here. So, for example, right now we're seeing the first 5. And remember, Python always starts counting at 0. And we can see the name of the columns. We can see the values that are in the columns. And you can see right away we've got some missing values, which are definitely every data scientist or data analyst headache. We can see we've got different categories and so forth. So you can see the top of the data. You can also look at the bottom of the data, the tail like this. And then the next thing we might want to do here is try to figure out, because I can see here I've got this NaN, which means there's no value here. I want to get an idea of like how many missing values are there. So if I type in df is null, .sum, now this is going to bring back all the missing values in every category and every feature. Okay, so I can see that in age, I've got a lot of missing values, in income also. So you can see here, there are some of them that don't have any missing values, and then some of them that have quite a few. So that's something we'll be able to address, and it will be able to be addressed very easily in Python. And I'll show you how we can do it. But first, let's continue with just examining our data here. The next thing I can do, just to give you an idea of the visualizations, let's say I want to look at where the missing values are, and I want to visualize it. So I can create, by the way, if you want to comment something in Python, you use a little hashtag. So I want to create a heat map of the nulls. Okay, so here I'm going to be using the matplotlib library. So I'll use plt, and then I'm going to create a figure and then give it a size. And from here, so I made it 10 by 5, 10 is the width. I'm going to name it so that I can add other attributes to it. So now I'm using SNS, heat map is null. And don't worry, you don't need to know this. So if you try to memorize everything in Python, you will have a very difficult time. You will memorize basically whatever you're using the most often. But if you know the functionality, basically you know where something is, you know how to find what you're looking for. And that's the idea. When you don't need to by heart everything in Python, especially now that there's ChatGPT, is definitely not going to be necessary, because if you forget how to write something, oops, I always forget equals here every time. If you forget something, you can either Google it or you can go to ChatGPT, And now, of course, like I mentioned before, ChatGPT loves making errors. I don't know why it's doing this, but it does. But the great thing about Python is it tells you what's wrong with it. So like, for example, if I remove this again, let's just say I make a mistake on purpose.
Hashtag create a heat map of the null.
Sorry. I have my computer can read to me. So if I make a mistake, Python always tells you where the mistake is at. This is one of the beautiful things about Python. And in Google Colab. So it says fig size is not defined. So I would be able to go up here and look at it and see that there's a problem because of the red line right here. Okay, so this just gives us a nice visualization of all of the missing values along with all of the features names. Okay, so I can see the concentration of which ones are missing. The other thing you want to do when you first get a data set is you want to see what's duplicated. So we're going to look to see if there's anything that's duplicated. So we use a function called duplicated. Makes sense, right? You want to know it's duplicated, just use df.duplicated. All right, so then we also want to look for the variable types, so our feature types. So we want to make sure that the variables that are numbers are actually stored in Python as numbers, and then the variables that are categories are actually stored as categories. And so I can see here in Python, we've got several different variable types. We've got float, we've got int, we've got strings, we've got lists, but in general, floats should be numbers. Well, not in general, just very specifically, floats are numerical data. So I've got revenue, I've got age, income, credit score. These are all floats. Now, credit score, arguably, credit score could actually be a category. Since it's a number that actually represents a position, but we could also use it as a number. Month since last purchase, total purchases, and then we've got number of children. So I do see, if you see object here, object is going to be some sort of categorical variable. So when you get your data into Python, you want to just check it to make sure, like, I wouldn't want my revenue to be stored as an object. And if it was, then it probably means that there are some dollar signs or something in the data, which I can easily remove using Python. So the next thing I want to do is, because I have so many missing values, I want to look at the skewness of my data. Now, if you're not familiar with skewness, basically it's how different my data looks from what we call a normal distribution. So if it's different than bell-shaped, if my data is very bell-shaped, then I can replace the missing values easily with the average value of that feature. But if it's skewed, then I'm better off replacing it with the median value, which is the middle value of the feature. And here we're looking for values that are above or below -2 and +2. And the skewness isn't super awful. In fact, here it's mostly normal. And a lot of that might be because this data, I made this data, it's not real. It's a synthetic data set to represent customer revenue. So now we've got describe. This is going to give us all of the descriptive statistics for our numerical variables. So you can see we've got our revenue, we've got the count, we've got the mean value, 499, and I believe this is in thousands. We've got our standard deviation, and that's going to be the same. We've got our quantiles here. This is our median. The median is the 50 Q2, right? And we've got max and min. So these are our descriptive statistics. Notice that here we'll only be able to get the descriptive statistics, of course, for our numerical values. Okay, so the next big thing to do, now that we've kind of got a feel for what this data looks like, we want to clean the data. And so by cleaning the data, we will want to remove these missing values or replace them with some acceptable way of replacing them. So there are lots of ways to replace missing values, but in general, you want to, if your data is not skewed, you can replace your data with the average value of that feature. If you have a category that's missing values, you can replace it with the most frequently occurring category, or if the values are missing between two rows, and it's so basically if you're missing missing one observation and you know it's in the part where they're all the same category, you can just use that category. Okay, so there are lots of different ways to replace missing values. And there's also there's a way to automate it. Yeah, you can use interpolation. Yeah, very good. But generally people use the mean or the median, or they use some functionality called simple imputer. Okay, so what I'm going to do here is I'm just going to use the median, because even though my data isn't skewed, I always feel better using the median value. So I'm going to replace fill with the median of each column. And let me just check to make sure my where my code share is at, the last code share thing I've got. Okay, let me give you some more here. So those of you who are following along using this, you can get to where I am at. And skew. And also, I think I can share this if it's fine. I can share this notebook with you, so you can have it and you can study it. All right. So now let's go back and fill our missing values. So first thing I'm going to do is take my data frame is df. So I'm going to fill the NA's command. Okay. And then what I'm going to fill it with? The median value of each of the features. And then I'm going to use a command called inplace equals true, which will make it permanent. So if you don't use this command, then your changes won't be permanent in the data frame. All right, so that's fine. And then I also want to convert my categories from objects into a category. So here I'm going to grab my categories and I'm going to make a list of them. So here I'm going to type the name, category, because that's one of my categories, gender. And by the way, if you can't remember what they are, we can go like this, df columns. And this is going to return back all the names of our different features here. Okay, so we've got gender, and we've got education. Oops. So you have to use these quotes. You can use single quotes or double quotes. And this lets Python know that this is a string. A string is a data type that is non-numeric. But sometimes string can be converted to numeric string. Okay, so here's the first section of what I want to do. Now I'm going to copy and paste this. So basically I'm going to say, okay, select in my data frame, select these columns, and then convert them to as type category. So as I mentioned, the learning curve at first is a little steep, but once you've got it down, then it's going to be much more easy to work with data in Python. So what I want to do now, I want to, I don't want to save that, do I? No, let's just take a look at it. All right, so now I've done this. And let me give you this code here. So now when we look at the data, hopefully we don't have, we don't have any, we don't have any missing values anymore. So there you can clean the data. So we can look at df.info. And now we can see every non-null is, so non-null means like it's not missing, is 75,000, and that's the number of rows in our data set. And all of our categories are categories, except for the days since the last login, which I have not changed that one. So now I want to skip ahead in this process so that we have time for Q&A. And I want to show you the power of Python with respect to EDA, so exploratory data analysis. First, let me give you some code here. And I'm going to stop typing the code directly and paste it here. So what I'm doing here now is I'm going to separate my variables. So I'm going to separate my numerical variables and my categorical variables into their own little data frames so that I can operate on them independently. Which means like I can write a function to give me back all of the information that I want about the categorical variables and about all of the numerical variables. Okay, so let's see, do you have that in the code share? Okay, so you can get that from the code share. And so what I'm going to do is, first of all, I want to look at each of my categories, and I want to get the count of each level of my categorical variables. So I'm going to go through my list here of my categories. So this is, by the way, this is called creating a list, and the method I'm using is a very, what we would call Pythonic method, meaning that we're using a list comprehension. A list comprehension is a very Pythonic way to create a data structure called a list. And my list is all of my categorical columns. Okay, so I'm going to say for column in cat calls. So I'm going to loop through my list here. I want to print my column, and I want to print the number of observations or the values in my column. So we're going to use something called value counts, which is very useful, and you should learn this one right away. And then we're going to take a look at what we get. So let me give you this code here. And so what we're going to do, we're going to see all of the counts of the categorical variables. Okay, and so now we can see in the home category, we have 15,000, or so, sorry, in the category, I don't know why I named this category. In the category, we have home, apparel, food, books, electronics, and then we can see all of the different observations that are within that particular subset. Okay, and then we can see our gender, very equally distributed, again, likely because I generated this data myself. We have education. We can see our distribution of bachelor's degree, PhD, associates, high school and masters, and so on and so forth. And this is a very quick way to get the counts of all of our categorical variables. Now we can also go ahead and look at, for example, if we want to answer the question, which is going to be an exploratory data analysis question, we want to know what is the average revenue per category. We can do that as well. And the way I can do that is with a function. And a function is like in Python, we can create a function that will allow us to reuse that functionality in different instances. There we go, that's better. So here I've already written the function, and I'm not going to type it right now because the time is dwindling. So let me paste it here, and then I'll paste it in the code share, and then I'll show you what we can get from it. Okay, so let me just explain what it is. This is defining the function here. And what I'm doing is I'm taking my data frame as one parameter, and I'm taking the columns, the features, as the other parameter. And so it's going to return, so it's going to give me back for each column the revenue mean. So it's going to group everything by categorical column and then give me the mean revenue for that group. Okay, so also it's going to store them all in this data structure here, which is called a dictionary. And so we're going to put the results here, and then we're going to print it out here. So let's take a look at what it does. So as you can see here, I can get the average revenue for associate's degree is 500, bachelor 499. And then some of them, like for this, this is the education right here, right? So there's a NaN here because this is a different category now. So that's pretty useful, but probably better than that is going to be looking at a visualization. And that's another place where Python can really excel. So excel, that's ironic that I used that word, where Python can really do well and excel. Okay. So let me give you this next chunk of code here. And what I want to do is I want to look at the average revenue per category. Okay, so here I've created a function. Again, it's taking in my data frame, it's taking in my categorical columns, and it's taking in my target column separately. All right, and then I'm creating a figure and I'm basing it on the number of columns so that even if I have different number of columns, it can always figure out how many columns it should use. So that's what this little line is doing here. And then once I'm in here, I'm creating a box plot where I'm taking the target variable in the data frame, and then I'm creating different, creating this AXI because I'm going to create more than one. And this I is saying that I'm taking each of the columns. So it says for I in column. So basically this I is going to allow me to go through each of my columns and get the box plot of the average revenue. Okay. So did I paste that in the code share for you? So now just shift enter here. And we're going to see the magic of Python after we call the function. So we do need to call the function and we do need to pass the argument. So let me grab that little chunk of code for you. So to call the function, you just use the function's name, and I'm going to paste this in code share for you. And then you pass in the arguments that you want. So here, the function that we made here, it's called average revenue by category. And then I'm passing in the data frame that I'm using, the columns that I created, and then the target variable, which in this case is revenue. And now we see the magic of Python with respect to visualization and automation. In this, you can see everything. We've got automation, we've got scalability, we have reusability, and it doesn't matter, how many observations we have, we're able to do this. And I get these nice box plots here. Of course, my revenue is all uniform because, as I mentioned, I created this data set myself using Python, of course. So Python created this data set for me. And it didn't give much variation, but you can see we can get massive amounts of information in a matter of moments. And, when you're doing your analysis, when you're using this sort of thing, you can have this definition. And by the way, I'll give you this so that you can use it. So next time you're doing your analysis or something, you can just use this code, right? Because it's already written. And then I'm running out of time, but I want to show you one more thing, and then I think we might go a little bit over for Q&A if that's fine. And I just want to show you this function that I have for quantitative variables. Okay, so first I'll paste it here. So quantitative variables, if you don't know what those are the numerical variables. So we just looked at our categorical variables. We looked at what might be considered a KPI. We looked at the revenue per category. Now what we're going to look at is the quantitative variables. And what I want to look at are the descriptive statistics. So quantitatives are the numerical variables. We're going to look at the descriptive statistics. So the mean, standard deviation, and skewness. I'm going to add the skewness on there. And then we're going to look at a box plot and a histogram, which are the two basic visualizations that you really need to be able to analyze quantitative data. So first we run this code here. And I think I pasted it for you yeah, I did. And then after we've got that run, we can call the function and pass in the arguments. So here here's the function name. I'm going to call it. I'm passing in my data frame. And then these are the numerical columns that I separated in an earlier step. So I'm just going to click this. And now you can see the magic and power of Python is automatically I've got the descriptive statistics for each and every numerical variable. So I've got the count, I've got the mean, and importantly, I've got the skewness, which I had to add this. So this this is a customization. Normally the skewness doesn't come on your descriptive statistics. I've got my box plot so I can easily see outliers. Oops, that got really big. I didn't want it to do that. There we go. I've got my box plot so I can see my outliers. I have my histograms so I can check for normality. And I can, for, you know, whether or not it's bell shaped. So I can do this for each and every one of my quantitative variables. Okay, so now let me go back here. So that is the basically the demo, the end of the demo that I wanted you all to be able to see. And I will paste this, I'll share this link with you. And so now I think if it's okay, if we could have about 5 more minutes longer, we can open up for Q&A.
We definitely can. And thank you once again, Jeffrey. It was a very intriguing session, I must say. And I'm pretty sure our participants would have enjoyed. I know you love to teach, and I hope participants would have enjoyed it as much as we did. Okay, so thank you once again, guys, for being part of this session. Yes, Christopher, 1 hour is not enough. And that is the reason why we have courses, we have certification programs, we have MBAs, we have DBAs that we go ahead and offer. And just to add to that, there may be some people who will be thinking after watching this, well, it's tough, it's not something that I can do. Trust me on this. It's not that hard, okay? All you need to do is practice, understand, and obviously, I can tell you that up front, if you go ahead and give us, I don't know, maybe 4 months of time, we can go ahead and make you do the same thing as he was doing already. Speaking of which, guys, if you have any question, feel free to go ahead and type it in. Yeah, Jeffrey, you're saying something.
Yeah, that's something I really meant to share. And I'm glad you mentioned it, because I meant to share this. I want to tell everybody that this is what you can do with just 3 to 6 months of Python, depending on your time availability and your discipline. So what I've done here is, if you only study Python for 3 to 6 months, you could easily do that, or even exceed what I did here. So thank you for bringing that up.
And just to add to that, Jeffrey, can you let the people know how many people have you trained who are not from even science background and can actually do that?
Anybody can do it, because, well, if you can read, if you can follow instructions, so many people I've been able to help, because if you have a question, it can be answered. Okay, it's not something mysterious, and it doesn't require any background, really. Everything is taught to you from step 1, and the job of a data science trainer is to hold your hand and walk you through the simple things so that you can get that foundation. And I've been able to help many people to overcome, first of all, their fear, and then also to get focused. So that's another big problem that another challenge that you're faced with when you want to learn data science is the matter of focus, because there's a saturation of data science courses out there. And if you don't stick to one, you're likely to keep skipping around and not really getting very past the basics. So definitely, many people I've been able to train from people who didn't know, they didn't know how to upload a PDF, like this. And now they can write for loops in Python, something that even I at one time thought was going to be insurmountable. Okay. But you develop a fluency just by practicing, debugging, getting confused. That's a good thing. That means you're about to learn something. So like this. Yeah.
Awesome. And it's great that you brought that up. That is absolutely true. We have faced it with a lot of students also, people who hardly knew how to use computers. They were still struggling with Excel and tools as such. And now they can write beautiful codes and, make sure that, working as a data science professional, what else can I say? That's the whole point. And as, Jeffrey already mentioned, learning in the world that we live today is more or less free. It's not something that is hard to get. It's just that the structure is important. You follow one guy, do not go ahead and follow everybody that you come across. So these are few things that you will have to keep in mind. And that is why we have structured our programs in such a way that, you can have the andragogy properly planned, when you go ahead and study. I'm getting a few questions. I think, Jeffrey, you can see them in the chat too. Is there any similarity between SPSS and Python for data science?
Okay, that's a good question. Now, it's a good question, but I know very little about SPSS, although I know that it's a program for statistics. And what I know about SPSS is that it's designed specifically for statistics, and that it's if you've ever seen the book Discovering Statistics by Andy Field, Professor Andy Field, he has a book called Discovering Statistics Using SPSS, and he also has one called Discovering Statistics Using R. So using SPSS, you're going to have a lot of drop-down boxes and so on and so forth. And so it's very fixed, but it's user-friendly, I would say. I wouldn't say that it has the same scalability of Python and the dynamic functionality of Python. Yeah. So there's a big difference in that regard, because Python is basically something that you can do so many things with. SPSS, you can do, it's for statistics, made by statisticians for statistics like this. But I think the ease of using SPS might be pretty easy. Yeah. So that's
while you were answering that, I did a quick search on ChatGPT, and this is what I came across. So I'm just sharing it. And this is again to define the power that artificial intelligence possesses and the dependency that people are starting to have on it. Okay. So that's the whole point. And guys, the world is different nowadays. You've seen how things are changing in the last, I don't know, let's say 6 months, how it is. More dependencies getting into artificial intelligence. The way that we work is changing. You have a personal assistant at your disposal now, that you can use to make your productivity even better. So there's no better time to go ahead and learn artificial intelligence or data science than today right now. Okay. I also have given all of you option right now that you can unmute. So if anybody wants to ask a question also, they can do that. Or you can feel free to go ahead and chat also. I'm also keeping an eye on our social media platforms. I see there are a lot of people. Madhu's watching. Anis is watching from LinkedIn. There are a few others on Facebook also. So if you have any questions, guys, feel free to go ahead and just let me know. Okay, we'll wait for another few minutes.
I see one question here. It says from Pin Apps. It says, I know that there are many opinions about this, but if a person will be studying for an hour a day, how many months will it take specifically Python for data analysis and
That's a good question.
Okay, so I have not done a study on this, but from my personal experience, just to get the basics of Python, I would say a minimum of 3 months. And maybe it's not an hour a day. It could actually be a little bit more, because sometimes you encounter problems when you're learning Python where you learn what programming is about, which is debugging. Yeah. So it may not be able to fit into an hour a day schedule unless you just have, a finite amount of time. But I would say probably on average, without having done any study at all, I would guess it would take you about 3 months to get the very basics. And then if you want to learn more about APIs or about flasks or about deployments, about logging, these type of things that you're going to use in your industrial data science, you might need another 3 months or 2 months.
Well, let's put it this way also. Monday to Friday, let's say you put in 1 hour because that's your working days. Saturdays and Sundays, you can even go ahead and put in like 3 or 4. That will probably help. And as Jeffrey already mentioned, it's not about how much you will learn. Python is a language at the end of the day. It's just like any other language. The more time that you put in, the better you will go ahead and get. I speak English. Jeffrey speaks a lot better English than I do. But somebody, William Shakespeare speaks even better English. So same is the case with Python also. The more you practice, the more hands-on that you get, the better that you will get, at the end of the day. But again, as you mentioned, what we recommend, we have trained a lot of people. I've been doing this for the last 8 years, approx. Okay, so 1 hour a day is suffice during weekdays, but you will have to go ahead and pitch in more hours during the weekends. Okay, it's important. If you're learning Spanish, if you're learning English, if you're learning German, it's the same logic. You'll have to speak that language. So same goes with Python also.
And I could say probably the key variable when it comes to success with mathematics or with programming is the time in chair variable. So if you can sit in the chair and do the work, the more time you spend, the better you'll get. That's the beauty of it, but it's also the difficulty, right? Because you will get out of it what you put into it. Yeah,
that is very well said, Jeffrey. Anybody else has any more question, guys? Otherwise, we are going to go ahead and call it today.
I see one question here. It says, as a student interested in data-related tasks, should I consider learning other languages such as SQL? So SQL is an important part of data science, but also while you learn SQL, so first of all, I don't know if I think I did mention this. You can use SQL queries from Python. So, but you do have to know the SQL query language. But more than SQL right now, because the data is getting larger and more diverse, so we're having unstructured data that's not like a spreadsheet. You have images, you have sound bites. So people are turning to things like MongoDB and Cassandra and other sort of data storage, data warehouses, data lakes. So you might also want to consider learning MongoDB. That's a good place to start. There's one more question here. Karen, sorry you got cut off, Karen. I'm not sure.
Karen says, do you offer data analytics? Do you offer payments? Well, yes, we do. And I just pinged her and she has shared her information. So Karen, I'll go ahead and arrange a call for you from one of our counselors who will help you with this. Okay. And just for everybody else also who wants to know, we have flexible payments plans that we offer to all our students. And that's more or less for all the programs that we have, whether whichever stage you are in, whether it's for your certification programs, which is a 6 months program, or for our MBA programs that we run, or for the doctorate programs even. So connect with our counselors. They will go ahead and check your eligibility and will guide you accordingly. Adrian says, what's the most common SQL dialect? Jeffrey, this is for you, I guess.
I would probably say MySQL. That's one that's easily, you can download that onto your PC. And then after that, maybe like SQLite. Yeah, probably MySQL. It's good.
Martin says, for non-programmers, where do you think we can start? Where there are work that needs filling to get our hands on learning coding, while we have some entry jobs. I think SQL with data science, it's a bit easier to learn. You're not wrong, absolutely, Martin, but I'll let Jeffrey fill you on that. Okay.
So where can you start? If you want to work in data science as a fresher, it's not so easy to go on LinkedIn and just choose every easy apply job and click 100 applications, because there are 300 other people doing that. So what you need to do is find a place where you want to work. And if you cannot get an internship or a data science interview, then get another job. For example, quality assurance. So you could start in this part of the corporation and then move over once you're hired. So you have to do this sort of out of the box thinking when it comes to this industry, because like I mentioned, if you go to LinkedIn right now, you look at the data science job descriptions, they will be all different. And they will all require, they'll all say different things, right? So what you have to do basically is start with internship, and then secondly, just get your foot in the door, build a portfolio.
That is true. And it's interesting that Martin actually asked that. Tomorrow I have a session that I'm taking. It's a 3-hour session for our existing batch on the same topic. You know, how do you go ahead and work on the same? So Martin, just to add to that, you know, obviously I cannot go ahead and dedicate that much time right now, but there are different ways in which you can approach. There are, resumes, how you need to prepare it, platforms, internships, as Jeffrey mentioned. How do you showcase? If you get a chance to, get in front of a recruiter, how do you present yourself so that you make the best out of it? So there's a proper approach that, we have quantified. We go ahead and help you with that part also. But having said that, it's not easy, but it's not impossible also, because it's a welcoming industry right now. There are so many people who are moving towards data science, obviously, because there's a deficit in the industry. So, that's how it is. And I don't know how many of you know about it. I hope all of you do. But with Metaverse, Web 3.0, all this coming into the picture, artificial intelligence is nowhere to go. It's only going to go ahead and boom more and more and more. So that's more or less, it. We have run a bit over time, and I don't see any more questions coming up. So I'll just wait for 5 more seconds. If there's one more question I get, I'll go ahead and squeeze that up. Otherwise, we will go ahead and call it today. Anybody has anything to say, guys?
I would like to add one more thing to the last question, and that is one thing that could be a mistake is trying to get at the job too early before you're ready.
That is
so
true.
I think it's a really good idea to build a portfolio, and in each of your projects, you need to know the story of your project. So you can tell the story of your project to a recruiter. You can tell them the business problem, the problems you encountered, how you overcame them, and the whole gist of it from front to end. And this way, when you do get that interview in front of the recruiter, you're telling them a story, and they're not asking you questions, you're telling them a story. You see what I'm saying? So you have to be thinking like this.
That is true. Pen says, before learning SQL, Power BI, or Python, please learn Excel first. And Pen, it's interesting that you say that. That is how we go ahead and start our programs also. We start with advanced Excel, because then you have the mathematical approach towards things. You build the logic behind what you're doing, and then you move on to the Python. So obviously, I totally agree with what you just said. All right, I guess we will go ahead and call it a day now. Thank you, Jeffrey, once again. Thank you for taking out time. I know it's been a busy day. It's weekend. And thank you once again for taking out time, from your busy schedule and enlightening all of us with your insights.
And thank you very much. It's been a great pleasure of mine to be able to assist anybody in their data science journey. If there's anything I can do to help anybody out, just you can ping me or get in touch with Sanket. I'm very happy to be a source or resource for you. Okay.
Thank you, guys. Thank you. And for those of you who are asking, the recording, the session was being telecasted live on all our social media platforms. So you can go ahead and go on our YouTube channel, and you can watch this video any number of times. Okay. With that being said, we are going to go ahead and take a leave now. You guys have a wonderful day ahead. Bye-bye. Take care. Enjoy your weekend and stay safe. Thank you once again, guys. Thank you, Jeffrey. Bye.